Today, I promise to give you a different approach to design controls and design planning. When I say different, I think it's important to understand different from what perspective. Normally, we're talking a lot about 510K submissions and design controls for 510Ks. The way I started out my career, I was focusing on CE marking and technical files for CE marking. And so the way that I learned to create design plans and design specifications was a little different from, I think, the way a lot of people create them for a 510K product. And a lot of companies eventually are going to have both. They're going to have something that has a 510K, and they're going to have something that has a CE mark, and they're going to have design documentation for both of these. In a perfect world, you'd have your documentation meet both requirements. Unfortunately, what the technical file requires and what the 510K requires, not a lot of similarities in a lot of ways. Even though they both require you provide a section for sterility, a section for reprocessing, a section for biocompatibility. Even though the sections are the same and they reference the same standards, that doesn't mean they're the same. And I think the fundamental difference here is because we are all spread very thin and trying to do more with less, we try to do things at a high level. And that works fine for the very beginning of the design project, but it falls apart at the end of the design project when you actually go to submit things. And at some point along the way, we have to transition from we're not doing this at a high level anymore. We have to do this at a very minute level of detail. And I think that stage is probably when you're going to prepare your testing plan in detail. And so that's where I'm going to give you some different approaches that I used to use for CE marking to explain how I do design planning when it's my project, when I'm not a consultant and I'm not just giving you advice, but when I'm actually designing a medical device. This is what I did to make sure that I didn't leave out any requirements versus what I see companies doing all the time. And people don't want to do it to this level of detail, but I'm becoming more and more aware that there's really no way around it. And they're all going to do it eventually. They're going to suffer because they didn't do the planning up front, and they're going to end up doing things twice. So let me explain the fundamental difference, and I'll use a really simple example. Let's take the example of biocompatibility. Everybody, unless they've got a ventilator device that uses a different set of standards, normally the standards that you're using for a medical device for biocompatibility are ISO 10993-1. And then the supporting series of standards below that. So you have a -5 standard for cytotoxicity, you have a -10 standard for irritation and sensitization, you have a -11 standard for how to do the extractions, you have a -7 standard for your EO residuals if you do EO sterilization. There's this list of standards, and they tell you what test methods you're supposed to do, what the acceptance criteria should be, but there are decisions that you have to make when you apply those standards, and not everything is do step 1, 2, 3, 4, and there are no exceptions. There are decision points, there are variations that still comply with the standard, so they're not always the same. And a good example would be when you're doing the extractions, they want you to do a polar solvent and a non-polar solvent. They want you to use surface area or mass for calculating the ratio of solvent for the extraction to the specimen that you're actually doing the biocompatibility testing on. And last but not least, there's a temperature associated with that extract and a time period that you're going to do the extraction for. So you've got to pick two solvents. You've got to pick how much solvent to the specimen you picked. You got to justify why that's the worst case specimen for what you're doing all your testing on. You've got to pick your temperature and you got to pick your duration. Now, one would think that you would always do it the same, but that's not the case. There are some things that are not compatible with certain solvents. there are certain things that degrade at higher temperatures. So you can't always use a cookie cutter approach. And that's the issue. It's we're trying to apply a hammer and nails to every solution when sometimes what we need is a screw. Or, you won't always want to use 37 degrees, but sometimes we have to use a lower temperature. Or you always want to use cottonseed oil, or you always want to use saline, but those might not be the suitable solvent. I'll give another example. I was working on a contact lens case, and the only part of the contact lens that comes in contact with the contact lenses in the solution is the inside. But how do you just test the inside to the right volume of solvent? Do you test it with, you put the solvent inside there, close down the lids and shake it around to get your contact with that? But that's not the right ratio of solvent to surface area. Or I could take it out of the, I could take it all apart and I could just do the pieces, but then I'm extracting on the outside of the case, not the inside of the case only. And that changes my surface area ratio to the part that actually sees the contact lens solution. Another thing to keep in mind is the FDA is very specific. They want you to do a longer period of time for the extraction, 72 hours at 37 degrees Celsius, whenever you have a device that's going to be used for a prolonged contact period. So if you put these contact lenses in your eyes every single day for a year, the cumulative use is more than 30 days, even though the individual use of that contact lens case, you might throw it out every month. So it wouldn't exceed 30 days. So which one do you use? Well, the FDA would come back and say, we would prefer that you do the 37 degrees because that's worst case scenario. And we want you to do it for 72 hours, not 24 hours. That's the worst case scenario. And we want you to use surface area and not mass. We don't want you to dilute the samples. They're all kinds of things that are in the FDA guidance that they want you to do. When you go over to the European side, you're going to see a different set of guidance documents on what they want for a specific standard. So Europe has what they want for how you apply those standards, and the FDA has what they want for how they apply their standards. You cannot make both of them happy all the time. Sometimes you have to write a rationale for why you're going to deviate from one of the two. And you have to pick one, and you have to write a scientific rationale. If you wait until after you've done the testing, that's too late. You're almost guaranteed you're going to have to go back and repeat some testing. So if you don't want to repeat your tens of thousands of dollars of testing and have delays of getting your regulatory approval, whether it's Europe or the US or some other country, what you need to do is sometime before you spent the money on the testing, before you paid your deposit, before you sent your samples, you have to nail down what version, what guidance document am I going to follow and why, and I need to write my rationale for it. Now, in a perfect world, I would have a pre-sub and I would get the FDA to agree to it before I go doing that. But that's not always possible. Sometimes we miss something and we forget, so we have to make a decision. But you are so much better off reading the guidance, getting expert help, writing a scientific rationale, and going with it than just doing the standard testing method with no justification, no thought to it. Just, we're going to follow the standard. That's what it says. That's what we're going to do. Another thing that's a bad idea is just to blindly say, okay, we'll do what the FDA wants, and we'll worry about the CE marking later, because then you're going to pay twice. You're much better off, say, time out, let's discuss this, let's get an expert that knows both requirements and make a decision as to which one we're going to do, so we can explain it to the FDA proactively. In our submission, we can say, there's a conflict here. Europe requires this, US requires this. We determined this is the worst case scenario, so we did this testing. They'll accept rationales. It's not that they won't accept them. It's just that you didn't take the time to write one before you submitted. And you waited until you got a deficiency and then tried to backpedal and come up with a good explanation. Come up with a good explanation up front. Come up with your rationale up front and get experts to weigh in on that and give you some pointers on how you can reword that. And it's for every single test that you have to do. So here is how I structured my CE marking technical file design plans. What I would do is I would actually go section by section, clause by clause, all through back then it was the ERC, the Essential Requirements Checklist. This is Annex 1 of the MDD at the time. And I would go through every single requirement and say, how am I meeting this requirement? If it's not applicable, that's fine. But before I would do the testing, I would figure out what test report, what verification test is going to meet that requirement. And I'd make sure I had a protocol and not just a standard over on, you have your columns. Here's the requirement. You copy and paste that in. And then the next column is the relevant harmonized standard. You don't stop there. You got to go all the way to the protocol at the far end. In line item, we're going to use this version, these settings, this specimen. You've got to spell it out. And you need to do it before you do your testing, not after you do your testing. That's just the fundamental difference there. It's just the sequence. You're not doing more work, anybody. That's not what I'm asking you to do. I'm just asking you to change the sequence in which you do the work. Instead of waiting until after you did all your verification, validation, testing, and after you spent all your money, and after the notified body or the FDA told you did it wrong, or you didn't comply with a guidance document that they have because you were satisfying somebody else's guidance document, before you get that far, take a step back and say, let's figure out how we're going to address the requirements of the different markets we're going after before we spend the money and submit the samples. That's all I'm asking you to do. You're going to have to write that rationale one point in the process anyway. Do it early instead of after the fact. That's what you need to do. And you have to do it at the line item detail level. Now that we actually have an E-Star template, the E-Star template is much more like the GSPRs, the General Safety and Performance Requirements of the European MDR, than it is like something else. The FDA has gotten to the level of detail now where they've said, for this requirement, answer this question, yes or no. Do you have a sterile device? Do you label it as sterile? Yes or no? Do you provide it as sterile? Based on that answer, a section will populate or it won't populate. If it populates, now you have to tell them the method of sterilization and you have to provide a summary of it. So the best thing to do is during your planning process, open up that E-Star template and go through each section, answer your questions to try to figure out what things are you going to have to address when you upload those reports. So you know what nuances or little requirements that you didn't realize were in their guidance document that you have to include in your testing plan. I guarantee you every single one of those sections has something that could catch you, that you would forget, you wouldn't realize they want that little piece. It doesn't matter what section. It could be the labeling section. It could be interoperability. It could be usability. It could be reprocessing, sterilization. It doesn't matter. Every single section has it. So you need to go through that template. They built it by taking all the reviewers' comments, all the reviewers' help and guidance and checklists, and all the guidance documents the FDA has, and said, ask this question, and based on the answer, we need this information or we don't need this information. And then you have to decide if it applies to you. Let's make sure you know how you're going to answer it in your testing plan. Now, if you're going to do two different countries, Europe and the US, all you have to do, people, is add another column. Remember, you have the requirement, you have the harmonized standard, and you're going to have a column that says, here's the test method. Well, now you're just going to add you're going to have two columns instead of one column. Instead of just the GSPR requirement, you have also the FDA requirement. And you can say, well, this is where that requirement is. It could be what page, it could be what section, however you want to identify that particular section. It's not line item in the same outline format that the GSPRs are, but you number it however you want to number it and make it very clear. This is a requirement from this checklist. This is a requirement from the E-Star, and then you can make sure you didn't miss anything. Another thing that I did that was different is your GSPR is really long. It has 23 different sections. You can try to eat that elephant in one bite, but I don't recommend it. You're going to get a stomachache. Instead, break it down into sections. They're numbered. You have section 1, section 2, section 3. There are 23 sections in there. Go figure, there are 20 sections in the old 510K format, and there are a little less than 20 sections in the new 510K E-Star. So you have two very similar numbers of sections here. There might be a rationale for why we have that many sections, because there are that many different requirements for testing requirements. So the direction I always go, because I go through it all the time through 510Ks, it's sterilization is number one. So have a little document that has your sterilization requirements. Now, we were just discussing this yesterday in one of my trainings on the E-Star internally as a team. And Mary Vaughter was saying, well, I think we ought to put it as a spreadsheet. That's how I'd like to organize it. And we're going to have different tabs for the different sections. Well, that's one way of doing it. But the problem with the Excel spreadsheets is the Excel spreadsheets are not really great for word processing and formatting documents, and hard to do searches if you're trying to find a specific word. They don't do word processing well. They do a really great job of allowing you to sort, and you can have all the things in one document, only look at one tab at a time. That they do well. But what they don't do well is word processing. Word processors like Word do a better job of that, but they don't allow you to have one document, one tab for one thing and one tab for another section. You have to have separate documents. So that means opening and closing different documents. I personally prefer the Word version approach, but neither one is perfect. So you could make a strong case for the Excel spreadsheet. You can make a strong case for the Word document. But what I think Mary and I would both agree on is you probably don't want to eat the 23 pages all at once, and you want to break it up into sections because it's easier to digest. And when you're talking with a lab and you're discussing in a design review a specific type of test, you're talking about that area. You're not talking about the whole submission. I don't need to talk about sterilization method when I'm talking about software validation. Those aren't related in any way, shape, or form. It's not the same test lab. It's not the same standards. It's not even the same components. Now, if I'm talking about sterilization and biocompatibility, there's some related features there. But it depends on what aspect of the testing I'm talking about, whether I need to talk about more than one area or not. But a lot of times what we're looking at is what materials should I use and what tests should I use? And people stop at the standard level instead of drilling down to what are the individual requirements. And I'll boil it down for you. It's pretty much the same across all standards. Number one, what is your sample? What is your justification for why that's the worst case scenario? You need to describe it. And if there are, depending on what the test is, you might have to specify what your sample size rationale is as well. What comes into play there is how many lots, how many samples from each lot, whether it's going to be a prototype or not. So is it a finished commercial version or is it a prototype version? And am I going to have to do retesting later? Those are some key questions. Am I going to just test part of it because it's too big to do an extraction of the whole thing? Or am I going to test the whole unit because it's a small part? Great questions. Those are the level of questions you have to answer just at the very beginning for every single test. My sample. Describe your sample and all the details about how you selected that as your sample for this test. Number two, what are the conditions? Well, you have your standard, and then what are the conditions and methods that you're going to use for that test? And then what are the acceptance criteria? And if there are any differences between what one country wants and what another country wants, you're going to have to reconcile that. There are going to be some rare occasions where you might have to do both. But most of the time, you can pick one set of assumptions over another because it represents a more worst case scenario and is more appropriate for your type of device. And the FDA will usually accept it, and the Europeans will usually accept it. Why? Because I've seen it done. I've seen it done both ways. I've seen US companies use their data for a European submission, and I've seen European companies submit their data for a US submission after they already had it in their respective countries. They had the approval first in those countries. So those are the things you need. The test method, of course, the description of the samples, the methods of testing, the acceptance criteria, those all need to be filled out for every single test, and I would do it section by section. So when you're creating your design plan, you're going to say, first stage is we're going to come up with a project and we're going to approve that project. That's the very early planning stage. The next stage is the design inputs. We're going to identify what the applicable standards are, and we're going to identify the risks associated with the product and any kind of regulatory requirements. And we're going to put those in there as our design inputs. When we've done that, we have to update our plan based on these inputs that we've identified. The next phase, we're going to develop our product and start working on risk control option analysis and trying different design solutions and coming up with final specs. During that phase, we're going to have some changes that we make that are going to require us to update our plan again. You do not want to wait until after you've done a design freeze, you've frozen your design, and you start sending out samples for testing to finalize what tests are going to be done and what conditions they're going to be done at. You want to be doing that in parallel with the development of your device, and it should be an iterative process. So as you go along, you say, if we did this test instead, that might work better for the materials we've chosen. Or if we made this change, if we made this decision on materials, we might have a better chance of passing these certain tests. If we chose this sterilization process instead of that one, it might be an easier validation process for us. So some of the decisions you're making where we could pick one or the other solution as a design solution could impact the difficulty of your testing, and what decisions you make for testing could impact your design solution. They feed on one another, and you have to really think about updating your design plan at every single phase as you go along, and it's an iterative process. You don't create a design plan and it's frozen in time. It gets updated and morphed all the time. Do it by sections. You got 23 sections of the GSPR. You've got about 20 sections of a 510K. Break it down into sections this is the sterilization section. This is the shelf life section. This is the electrical safety section. This is the interoperability section. This is the EMC section. This is the RF wireless section. Every single one of those sections needs to be considered. And a lot of people are like, all that shows up in section 17 of my 510K. Well, now in the eStar, they've really got 3 different sections instead of section 17. It's the electrical safety, the EMC, the RF wireless. And if you really want to look at it, they've also got in thermal testing in there and mechanical testing. So it's not even really electrical and EMC anymore. It's now a whole bunch of other things in there too. And each one is a different subsection. So you really have to think about how are you going to design your plan, design it at a much more detailed level than you ever have before. And why is this necessary? Our 510Ks used to be a few hundred pages thick. Now they're 2,000 pages thick. Along with that went a lot more testing and a lot more decisions and a lot more documentation. So your planning should be appropriately more sophisticated. It's not like we have to do sterilization validation and you're done. That might have been fine in the first week of your design planning, but when you're 10, 15, 20 weeks in, you should have a little more sophisticated plan that has the details that get down to the guidance document level and the preferences of one country versus another, and you have to make choices because there isn't an answer where yes, it makes everybody happy. It won't happen in all cases. You're going to have to make decisions. I hope this is helpful to people. For people that like, oh yeah, I know this, but do you do it? Do you actually go out there and make these detailed design plans before you go into testing? Because if you do, you're like 1 in 100 of my clients. The other 99, no, they wait until after they've done the testing and then figure out what they didn't do. That's why their testing takes so long. Spend more time on planning. Your testing will take less time because you can go ahead aggressively without worrying about whether you've forgotten something. You spent all that time during development also fine-tuning your plan, so when you got to the design freeze, you could pull the trigger right away and move forward. That's it for today's session. If you liked it, please click the like button below and share it with others. And if you have any suggestions for next week's, please put a comment down below. Don't forget to check out our other videos that are not live. We just recorded 3 of them and posted them yesterday on the YouTube channel. One of them was about small business qualification for the FDA. We've recorded that multiple times, but we updated one. It's got 7 steps, very clear and precise, and it has some links in there to our website where we have all the forms you can download right there. So that should help people that don't know how to get small business status. Number 2, we recorded one on how much does a 510K cost. I had done a longer one in the past that also kind of incorporated the small business qualification stuff. This one is a little bit more straightforward and simple that just covers the 3 basic elements: your FDA fees, your consulting fees if you use a consultant, and the cost of your testing, which is the biggest cost. The third thing that we posted about was a general eStar video that talks about the first few sections of the eStar. We also talked about the new FDA guidance document that was released September 12th on the eStar. We also talked about how you can now register and get your own CCP, customer collaboration portal account. If you don't already have one, the beta period or testing period is over, and now anybody can get one. And the third thing that we had in there also was eCopy is dead. The FDA announced with that new guidance document for eStars that the transition date will officially be done September 30th, October 1st of 2023. You are going to have to start using eStar. You won't be able to use eCopies anymore. We will probably see in the very near future here a pre-star. So that was the slang term that the FDA folks came up with for this new one. It isn't official at all. That was what I heard through the grapevine, but I like the term. It really helps people understand what it is. It's an eStar, but for pre-subs. So hopefully that will be the name they use because I like it, but that probably means it won't be what it is. You don't always get what you want. But what we do expect is that they already had one validated for 513Gs, and we expect them to expand that to cover the other types of pre-subs that you would submit. And then, of course, we have a new logo that goes along with the eStar for our FDAeStar.com website that's going to be coming soon. So we'll have a lot more content related to eStars. Every Thursday, we're going to be posting that. If you want to be invited to the live sessions and participate in the training on eStars, you have to buy our 510K course. But we have about 4 or 5 months of content that's going to be coming out there. And I think it's 30 weeks in a row. We have a few weeks where I'm on vacation or I have a conflict, but in general, you're going to have over 20 live sessions every Thursday at 9:55 is when we kick off. And so we'll be recording those sessions if you miss one, but you should definitely sign up for our 510K course if you want to get that new material. Thank you and have a great weekend. Bye-bye.